So the title of the presentation may be a little bit misleading because we've called it Echoes of the Forest, where do the macaws go? If you're expecting that I answer that, you're going to be disappointed. We're actually going to uncover more questions because we simply don't know. Um, but what we do know about the Great Green Macaw is that they're found across 6 countries. And this is maybe an optimistic or maybe an older range map, which shows sort of continuous distribution all through that area from Honduras in the north through Nicaragua, Costa Rica, where we are obviously, Panama, Colombia, and then Ecuador. But actually, if we look at more recent data like eBird, we find that there are actually isolated populations and they're more like islands. So this, where's my cursor? This population here is actually in the dry forest, which is interesting. This one is there's a subspecies described, and that's in the dry forest as well. But then this is all rainforest, and this is rainforest as well. And the interesting thing is, I don't. I'm surprised this goes as far as it does. I think this is not a very continuous uh, line here. I think that this southern Nicaragua population is actually quite isolated from the northern one. Um, so the first thing is like we don't know exactly where they go within these ranges, and we don't know how many there are. So that's kind of the first challenge. And but when we ask the question, why aren't there more macaws? We actually need a solid basis from which to ask that question. So we do population census work, and we've actually sort of catalyzed a census that actually took place across 5 different countries, 5 of the 6 range countries. This is a photograph that I took early one morning in Costa Rica, looking at the iconic volcano of Arenal. And we saw something like 140 macaws fly basically from right to left. Um, it was an amazing morning. And yeah, we got to count them. But even so, our census methodology is far from perfect. We're not getting an accurate number of the birds in Costa Rica. So that's actually the first thing we've got to measure because that is the way that we show our work has impact. Like ultimately, everything we do needs to lead to there being more macaws. That's a key thing when it comes to our work with the birds. We also work with the habitat, and that has its own thing, but ultimately that habitat's got to be there for a population of macaws. Um, so the challenge is we don't know how many there are, we don't know where they go, and you think, well, how's that even possible? Well, think about things like it. So I'm actually in Britain right now, and here in Britain, I have these birds coming, not these particular individuals, but blue tits coming to my garden. The Americans amongst you might be chuckling at the name. There's also great tits as well, and I also have a coal tit that comes to the feeder as well. So blue tits are probably one of the most studied birds ever. There's a population just outside of Oxford called Whittam Woods. That's a study area. And they've been studying them since the late 1940s. And there's been something like 350 scientific papers and 70 PhD students. Well, the Great Green Macaw's probably got less than 20 scientific papers to its name. And I think there's been 2 PhD students so far. But these guys are prolific breeders and they have like tons of eggs and then tons of babies and they'll have multiple clutches in a year. And and to study them is like a lovely little wander through the woodland as you approach your nest boxes. I remember talking to a research student that worked there, and they were whining about their work, and I was just like, you have no idea how easy it is compared to what we deal with when now in Costa Rica. I was in the Caribbean before, but now in Costa Rica, this is like the environment that we have to navigate to do our work. Um, so that's one side of the thing of like that's one of the excuses I give myself for kind of why we don't know all the things yet. We're still pretty new at this, and that's an important thing. And I'm reassured by the example of the Mauritius kestrel, which is a bird that I got to work with when I was 16 years old, and I went out to Mauritius and was actually feeding these. feeding released birds like this individual that's banded, their population dropped down to four in the 1970s. But if we look at this graph, you see that their population didn't really increase for something like 14 years or more before they got all the techniques dialed in, and then the population increased. So I think that that's a really important thing, and I kind of call this long duration bit the impact anxiety, because as the leader of an organization, I want to make a difference for parrots, but we need to know what dial to tweak in order to cause this rapid population growth. And we'll talk about that a little bit more. But the thing is, it takes time and it requires a certain amount of patience or an investment in order to know your birds. That's the term that Carl Jones, who led this project that saved this species and the echo parakeet and others from extinction. Um, you have to know your birds. So that's where we're at right now with the Great Green Macaw. So what we do know is that they are very fond of mountain almond trees, and these purple trees, the purple crowns here in the foreground, these two are mountain almond trees, and there's other ones dotted around as well. And the mountain almond tree is an incredible tree that produces massive hard nuts. Well, not massive, big nuts, and the macaws need this massive beak to tackle them. And these chicks from our breeding center, you can see just how enormous that lower mandible is. It's much, much bigger than on a scarlet macaw. And they need that to be able to crack open the mountain almond nuts. And this is a juvenile bird at the center learning how to handle a mountain almond nut. And it's got to drive the lower mandible in like a chisel. And this next photo, you see the seam of the nut, and it needs to find that seam and just maneuver its beak and then push that into the nut. It's incredibly tough to crack, and it's kind of fun because you get to see the birds like trying all different positions and then trying really hard. Like when you open a jam jar and you find yourself getting into all sorts of odd positions. That's exactly what this guy did, and then actually just gave up, which I think is funny. So yeah, so. The mountain almond is a really important food source for the parrots, but we know that we've lost a lot of forest. Originally, like back in the 1950s, that was to supply North America's booming fast food industry with beef. And so a lot of forest was cleared. More recently, there's been fruit, different fruit and monocultures. More recently, the expansion has been pineapple, which is what you see here. And it's something like 50% of the pineapple that's imported into the United States comes from Costa Rica, right here. Actually, these hills in the distance here, that's our reserve. Um, so the idea of habitat loss is something we hear quite often, and I gave this bit of the presentation in California recently in San Francisco, and so I kind of used an area that everybody in the audience would be pretty familiar with. So this is the Bay Area, and we're going to imagine that there is a guy called Timmy who lives in Menlo Park. Well, unfortunately for Timmy, we're going to do habitat loss. We're going to implement some habitat loss. And we're going to take out all of Menlo Park and Palo Alto all the way up to the airport. And then actually this area here is Berkeley and not Oakland, I think. Maybe a bit Richmond as well. And so all of a sudden that habitat's not available. The people from those areas have got to like move out as the bulldozers come and take out the infrastructure and the houses and the restaurants and the roads and everything. And so Timmy moves to San Jose along with an awful lot of other people. And so you can imagine then there's going to be a lot of conflict with the population that's already in San Jose. They're not going to like it. And it's going to be a very unpleasant time. And basically, they're not all going to make it. And that's what would happen in a wildlife situation. You would have mortality as a result of this. To make things worse, we have the second of three factors that we sort of hear the terms, but maybe don't realize exactly what that means, and that's fragmentation. And so For Timmy, he's got to get to work in San Francisco, but he can't get there because of this desert. And when I was growing up, Indiana Jones was having a lot of problems with quicksand. And I don't know if that's still the case, but I imagine that Timmy would have to, if he was going to try and get to work, he'd have to cross this area and deal with quicksand. And if he got past the quicksand, then he would have to deal with podiums where they make you do public speaking. So there's no way on earth Timmy's going to risk that. And so now he can't get to San Francisco. He can't get to his job, which represents what might happen for wildlife if that's where the food is. Now there's this fragmentation and they can't get there. Now macaws can fly long distances, but still they can't fly forever. And so large-scale fragmentation can be a problem. And I'll go into that a little bit more a little later. Now, the mountain almond tree is this stunning tree. They're 180 feet tall. You can see the house here. This is on our reserve. Everything in this photo is part of the reserve. And that's a two-story house. And this tree is in the front garden and it's towering over it. Not only do the mountain almond trees produce food, but they're also where more than 90% of great green macaws nest in Costa Rica. So they're a really, really important part of the landscape. And the problem there is the wood from the mountain almond tree is really hard and it's desired for construction. So these trees have been cut down and they're now protected, but before the protection was put in place, 9 out of 10 mountain almond trees were cut down. And even these days, we're losing hardwood trees. My dad visited me in Costa Rica, and I took him on a trip around some of the most remote areas in the country in the Land Rover, as of course you would do with somebody that's coming, your 70-year-old parent. So as we were bumbling along, we came across this group of guys with a bulldozer and trucks with logs on them, and the way they were behaving, I'm pretty convinced this was illegal logging. I'm totally convinced this was illegal logging. And so I've witnessed it firsthand, if indeed, and I'm pretty confident that was illegal logging. So how does that relate to our Bay Area? Well, I don't know if you like coffee. I like coffee. Timmy likes coffee, but Timmy can't get any coffee because there's so many people in San Jose. Whenever there's coffee in the store, as soon as it's put on the shelf, people are taking it off the shelf. So he's got to go to a coffee shop. There's 100 coffee shops here on the map now. And because of selective logging, of habitat degradation, this other term, the third term that we know, what does that actually look like? Well, if we take out 9 out of 10 of these coffee shops, this is what we're left with. And if you remember, you can't get to San Francisco. So those 4 in San Francisco are not available to you. And you're probably not going to travel to Half Moon Bay or wherever this is with where these ones are on the coast, or all the way up to Oakland. So it really shows you why why we get endangered species, basically. I mean, we throw out these terms: habitat loss, habitat fragmentation, and habitat degradation. Now, hopefully, you really feel it. And so when we ask the question, why aren't there more great green macaws? It's kind of obvious in a way, but we've got to have some science behind it. But what we know is that we've lost habitat. And so we know that protecting habitat is a good thing. So that's exactly what we've done. And this is the Macaw Recovery Network Reserve. And everything you can see in this photo, at least like not in the very far distance, but everything in this photo is part of the reserve. And that's thanks to amazing donors who've made that possible. We're also growing trees. We've got over 90 different species of trees, and we're empowering local women to do that work so that we're restoring degraded areas and putting those important species back. And here we've got Maria Elena holding the seed and Gendry, who are our long-standing women rangers, and they're now teaching a group of new women rangers from the area of the reserve, and they're learning how to do habitat restoration as well. So we've got our next next group of rangers, which is very exciting. The mountain almond tree is protected, but what happens is you end up with these trees that are standing on their own in the middle of pasture, and that's really not ideal, and the trees tend to fall into poor health. The thing here is that these are really important nest trees, and so we've been trying to understand what's happening with the population and investigating productivity, learning how many nests are producing, how many pairs are producing chicks every year, and what does that look like? What are the factors? Well, these are two young birds getting ready to fledge, having a look at the world, which must be a pretty scary thing when you've lived for 3 months inside the cavity, or 2.5 months at this point. Um, but what we found in the 5 years that we've been doing intensive nest observations, and there was a lot of work going on before that. There's been observations also showing that there's been productivity for many years. But we've done a bit more intensive work and found that there's loads of babies going out of the nest every year. So there's a very conservative amount. There's 20, but it's more like 30 chicks leaving the nest every year on average. And that's really important because that doesn't quite line up with the population growth. We were doing the censuses of the birds, and it just doesn't seem that if you've had 25 years of productivity, that's an awful lot of chicks, and the population hasn't gone up by 500 birds. And once those chicks have left the nest, there's a little bit of risk for them under normal circumstances, but then they should live a long and happy life for 50 years. And they have to have high survival in order to get to 50 years. So it's something doesn't add up, and that suggests that there is a problem with survival because we're having lots of babies. We've documented that the babies are leaving the nest. But the problem with the survival is it's much harder to determine because once they leave the nest, they all but disappear as far as we're concerned, which is kind of astonishing that you can have a bird this big that's this loud and disappears. But you also just saw the roads that where the logging truck is. It's not like there's lots of people roaming around who see the macaws. But we don't know really where they go after the breeding season sort of wraps up in May. But then it's not until September and October when we see large flocks of birds in this other area of Costa Rica, and they're having their social time, and which is kind of cool and amazing. I unfortunately didn't take this photo. I would love to see this many in one group. Um, but there's this period where we don't even know where they go. So understanding what their survival is really challenging. And what we need to do there is then monitor individuals, is what we've tried to do, and we've put radio collars on individual chicks. We can't really get hold of adults so easily, and then we track those individuals. And we've you're doing this over an incredible landscape, and you're just listening for a bleeping transmission from that collar. And we've done this, and we've had a master's student who came and did this work as well. And Noelia in this photo is an expert tracker, and she's done a lot of tracking before. Then we've had a master's student, but the technology that's available on radio tracking devices is actually really rubbish. And it's decades old, and we need to bring some more modern technology basically into this equation. The thing with the Great Green Macaw is that they will destroy anything. Like the parents will destroy the collar, or they'll be like, "Oh, what's this?" And then, "Oh, it's broken." And their beaks are so powerful, so it's really a challenge to track them. So we've thought, okay, well, how can we do this in a different way? And then there's this kind of innovation with tech that was really, really sophisticated, as you can see with the way that we attach them to the tree, where you've this passive recording device. It's a bit like if you were studying elephants, you might put camera traps out, and then they'd walk past the camera traps. Well, you don't really, that doesn't really work in a rainforest with macaws, but macaws are loud, so we can hear them. So this is an audio recorder, and it helps us map where the birds are going. And we've got this on a huge area. It covers 11,000 square kilometers. It looks like Costa Rica has the measles. These are every more or less every 10 kilometers, this spacing, and we get to see where the birds are going. And we've had a PhD student who's worked on this and done some preliminary work with this, and we're now building on that. This is Tom, who also did more specialized audio work and tried to identify individuals. And we found that, yes, in certain contexts, you can actually tell the voice of one macaw from another one, which was really cool. Um, but we've got the results, the initial results from the audio moth study, the big study, which shows us like when it's the breeding season, we've got lots of birds up here, which is where the nests are. Then they kind of spread out in the non-breeding season, and then the flocking season, they're down here. This is kind of the area where that group photo, the flock of great green macaws, was taken, and we see these large groups down here in prior to the breeding season starting over. So it's very interesting. This is very early stuff. We're refining the study, and then we're also hoping to do more pinpointing of the distribution in these areas. So there's stuff to do here, but this is what this is telling us is it's helping us build up a picture of the spatial and temporal distribution of the macaws. So where they go on the map and when they go there. And that's really, really interesting. And it can help us understand what's limiting them. But to do that, we need to understand the food resource availability. So there are six main hypotheses for why there aren't more great green macaws. That's according to me, this is. And a few other people that have not shot that down completely. So hypothesis one is that there just isn't enough food, and that might be in certain months, or it might be in certain places, or things like that. So we're trying to understand that, and to do that, we need to map the forest and understand what species of trees are where. So this is Hunter, who came down and did a study with us and collected very, very fancy drone imagery. It was sort of, I think, like 247 different wavelengths, not just visible light, frequencies. It's very technical, beyond me, obviously. But we're hoping that we can identify individual species of tree from this reflectance data. And that will then allow us to say where on the map there are certain trees. So we've been flying this over the reserve. This is from the neighboring pineapple area that we then flew over the reserve from there. To add to that, we need to look at when there's food. So we've got the spatial thing from the drone study. If we're piloting that right now, no pun intended. And then we will see if we can even extrapolate that to or take that to satellite imagery, which would be a lot more efficient. We also need to know when those food trees are producing food. So this is a palm with a beautiful pair of parrots in it, and there's racemes of palm fruit, but they're palm nuts, I think. But those racemes of food are not there all year round, you know. And if you're from a northern temperate climate, you'll be very familiar with, right now it's getting near the solstice, and it's there's not a lot of food on the trees, I don't imagine. But in summer, then certain trees produce food at certain times. And so that's what we need to understand for the great green macaw. The second sort of more convoluted part of this is relates to that fragmentation piece again. So in this is the breeding area of the parrots, and the reserve is somewhere here. And this is where we find most of the macaws, but they used to be seen all the way over here and up into Monteverde, which is over a thousand meters, and that is a migration that the birds are not doing anymore. And I suspect that they've lost the knowledge that that forest is even over there. And so that is sort of a bit of a concern because there's available food that they're not utilizing. Um, and if indeed, well, no, we're pretty confident that there's culture. We know, I mean, we think about elephants, and of course, it's been demonstrated there more concretely. But think of the matriarch elephant and how she leads the herd to to the water holes in the dry times. So I believe that the macaws are doing that same thing. I think there's evidence for it now. But if you lose those particular individuals, then that knowledge is going to be lost from the population. So then there's a challenge of how can we put that back? There's a patch of forest here. Maybe we can get the birds to bridge across. Um, and that's where reintroduction could play a role. We could restore a population over in the west there, and then eventually bring them back to meet the wild population. That's a lofty ambition, but certainly reintroduced birds can play a role there. Or if we discover that there is a food limitation, we might find that the wild birds don't want to use feeders because they're nervous around man-made structures. But then if we have reintroduced birds in those areas, what we've seen in other parrots is that those birds will teach the wild birds how to use the man-made things like nest boxes and feeders. So that's pretty exciting. The third hypothesis is that the birds are flying away somewhere and not coming back. So to the north of Costa Rica is Nicaragua. This is Lake Nicaragua here to give you orientation if you go and have a look at this yourself later. This river is the border between Costa Rica and Nicaragua. And then there's this big reserve here called the Indo-Maize Reserve, biological reserve, if we're going to assume Google's correct. Um, and this is our little reserve here, which we're hoping to expand. But the breeding birds, we know from past data that birds will go to Nicaragua, and it could be that they don't come back. And it's probably not because the it's just wonderful there and they don't feel the need to come back. What you can see here is that there is encroachment into this reserve. Well, you can't see that it's going into the reserve, but there is encroachment going into what is the reserve, and that's been facilitated by the current government. And there's cattle ranching going in, and we're losing forest there. And it could easily be that macaws are getting hunted and eaten because we know people uh, will hunt macaws and eat them. It's really hard for us to get any concrete evidence on that at this time. We can't work in Nicaragua, but it's certainly something we're considering as a possibility. Whether it would happen at a big enough scale that it would impact the population is a different question, but the combination of these different things could all add up towards that thing. The next hypothesis is that it's the genetic health of the population. And this photo shows a young bird. And I put this in because you can see the brachial vein near this person's ring finger. And we a little older, will just pop a hole in there and collect a tiny drop of blood that we can then do genetic analysis on. And we're collaborating with a fantastic university here in Britain and doing that work. This is actually a bird of the age we were actually taking blood from this individual bird on that day. And the next picture is like showing we don't stop when it rains. We just have to keep going when we get to this point. So this is just part of the field where we're trying to build up an understanding of the genetic health of the population. And I'd like to take that range wide eventually and look at the genetic health of the entire population. I, however, do not think that's limiting their recovery at this time. We've seen that there have been some chicks from wild nests, completely wild birds, that have had some feather deformation or poor development. And it could be that that's a disease. There's a cytosine beak and feather disease. However, we've not seen any evidence of misformed beaks or poorly formed beaks. So we don't really know. This could also be something about that particular nest site. We weren't thinking about disease when this happened a few years ago. This was a chick that needed rescuing, and then we put it up in a tree, and the parents came back, and then it joined the parents and survived. Um, but we were definitely thinking about the possibility of disease being a factor. So we're looking at that also with blood samples. We're looking at the disease risk and just trying to understand it, basically. And then the last hypothesis is that there are traditional indigenous people, indigenous populations, communities in Costa Rica, and there's sort of possibility that they may be having using traditional use of macaw feathers and collecting some feathers. For that to happen at a rate big enough to impact the population, I think we'd have to be losing a lot more. We'd have to be making a lot more headdresses. So I don't think that's really the big one, but we're including it, and it's something we want to understand better. These are all different hypotheses as to why we're not having more great green macaws. We're trying to understand it, and it's a partnership. I put this up because it's a partnership between uh, all the different parties involved, whether that's the research institutes we collaborate with, our team on the ground in Costa Rica doing the work, but also the support that we are so dependent on to do this work. And so I'm hoping that, like me, you want to see and experience large flocks of great green macaws. And we need to answer this question of where do the macaws go as a starting point to doing that. We need patience and investment to get there, and we want to have their calls echoing through the forest again. And so I would just love to encourage you to support this work if you're in a position to do so, and help us make sites like this a common thing in the future. Thank you very much for your attention, and you can always reach out to us on socials if you want to ask us questions afterwards. Just get in touch, and thank you very much for all your support.